Welcome once again to another lesson in geometry. Tonight we're going to talk about triangle similarity. We've talked about triangles being congruent. We've talked about triangles being similar. Now we're going to kind of take that same triangle congruent stuff we did before and apply it to triangles being similar. So once again, we got some acronyms we're going to do. So let's get started. First acronym of the night, angle-angle similarity, or AA with a little tilde symbol. That's angle-angle similarity. Basically what it says is that instead of looking at all the different pairs of sides and all the angles being congruent, once again we have shortcuts. We have a way to get from two triangles with some information to those triangles are similar for sure. And all we really need to have similar triangles is the angles to be the same. Well, if we have two of the angles that are congruent, we know that we're going to end up with the third one congruent too, because we have that third angle theorem. So the angle-angle similarity postulate just says all we really need are two pairs of angles congruent to end up with two triangles that are similar to each other. So here's our little example. We've got angle A congruent to angle D. We've got angle B congruent to angle E. And so we end up with two triangles that are similar because they have two pairs of angles that are congruent. All right, next one. Short little example. Because it's our first one of these, I'm going to go ahead and do it as the proofs that we were doing before. You don't have to write down your notes as a proof. I didn't put the little steps down for you. Just make sure you understand why these two triangles are congruent. So here's my little proof box. I'm going to take 4 steps to this. I'm going to start off with the only thing they really gave me other than the picture, and that's that PT is parallel to SR. I have those little double arrows there. Those little double arrows mean that those lines are parallel to each other. And that, of course, was given. Second thing I know, I have another pair of angles that are congruent on there. I need to have two pairs. So I got one that's from the parallel lines. That's angle P and angle R. I can see those, angle P and angle R. Once again, if you've forgotten your angle pairs, those are alternate interior angles. You'll notice that PT and SR being parallel, PR goes between them, we end up with our alternate interior angles. One more pair, the one right in the middle, Mr. Olivier's absolute favorite pair of angles, PQT and RQS, they're vertical angles. Always you have an intersection, you're going to end up with vertical angles, and they're always congruent. It's nice and easy to point out as one extra pair of congruent angles. So here, so far, I've got angle P is congruent to angle R, PQT is congruent to RQS. That gives me two pairs. Two pairs gives me angle-angle similarity, so I'm going to say my two triangles are similar. The catch, though, is that I have to get the points in the right order. So I'm going to say that PQT on the right, or on the left, sorry, PQT on the left is going to be similar to RQS on the right. I know that that's the right order because angle P was congruent to angle R, so I listed them first on both triangles there. And I know that PQT was congruent to RQS, those angles, which gives me Q being the same for both of them. So I put P as the first and R as the first, and then Q is the second for both of them, and then the subsequent letter T and S respectively. And once again, that reason was angle-angle similarity. So once again, the basics here is that you're just trying to prove two triangles are similar by looking at angles alone. You don't got to know anything about the sides. Although I do now know that I have some sides that are going to be proportional to each other. So I could do something with that later. But we're going to move on. Side, side, side similarity. Same acronym as we had with the congruent triangles. The difference now is that it's side, 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 and we're going to put a little tilde after it. So it's going to be SSS tilde. I'm not going to actually say SSS for this. SSS tilde. SSS similar, whatever you want to say. That tilde is a similar symbol. So basically what this is saying is just like the SSS postulate that said that if you had all three sides of one triangle congruent to all three sides of the other one, then the triangles are congruent. This is not congruent, but instead, since these triangles need to be similar, their sides should be proportional. So all I have to do is match up the sides. If I get all proportional sides, being that all my little ratios are the same, so in my case, I got AB over ED. That should be the same thing as AC over DF, and so on and so forth. I'm just going to match up all my sides, end up proportional relationships, and I'll get triangles that are similar. I don't have to worry about the angles if I know all of the sides. So either I know all the angles or all of the sides, and I'm going to be good to go. So let's do a quick example with this here. Once again, like I said, I don't know any angles, but I do know all the sides. I got those two triangles that make a nice little trapezoid. I got two triangles. I'm just going to start matching stuff up. So I know that PQ on the little triangle is going to go with SR on the bigger triangle. I could say that PQ is going to go with PR because I got isosceles triangles. It doesn't really matter which one I match up. I'm just going to say PQ and SR go together. And so I'm going to say that PQ is 4, SR is 6. That reduces to 2/3. So that ratio at 2/3 should be the same for the other two pairs as well. So let's go with the other half of the isosceles legs. I got QR and PR. It's another 4 to 6, which is, of course, still 2/3. And the last one, our longest side on our left triangle is that PR there, which is 6. And that's got to go with the PS, which is 9 on the right-hand triangle. So the longest with the longest. So 6 to 9, and that once again reduces to 2/3. Since I got all three of my proportions exactly the same, all my ratios the same, I know my triangles are congruent, or similar, based on side-side-side similarity. Okay, last one. Side-angle side similarity. Same deal. It looks like the same acronym. The difference is that we're going to say SAS with a tilde afterwards. SAS similar instead of just SAS by itself, because we don't have congruent sides here. The angle is still congruent. The angle B and angle E, you'll notice, are congruent there. But the sides, A, B, and ED, should be, instead of congruent, are proportional to BC and EF. So I know that AB over ED should be the same thing as BC over EF. So those should be the same, those ratios. And once again, this is a shortcut. If I know that I have two pairs of sides with the angle in between, then I'm going to end up with the whole thing working out for me. It's just a shortcut to getting the triangles that are similar. So here's another example. I've got two triangles that they overlap each other. They both have a vertex there at E. So I'm just going to do it the same way to that last one. I'm not going to worry about making it a proof. I'm just going to kind of list off the parts. So I know that JK on our little bitty triangle at the top goes with JM, that if I just extend the side the rest of the way. So JK was 2, JM was the 2 and the 4 put together gives me 6 total, which reduces to 1/3. And then on the other side, JL goes with JN, and that's 3 and 9, because I got to get that full 3 plus 6, 9, which reduces to 1/3. So far so good. I'm good to go. I have two pairs of sides that are proportional to each other. I either need a third side, which I obviously don't have, or I need to have an angle that's included between those sides. And if you look, both triangles have a vertex there at J, so they're going to share J. That angle is going to be congruent to itself, and once again, that's our wonderful reflexive property. And so based on that, I can say that my two triangles are similar to each other, and we're done. See you tomorrow.